Okay, number 2, you are offered a new job which has a $500 signing bonus if you stay a full 6 months on the job, plus $100 for each day you work. What you're going to do is create a table for this, a graph, and a formula. So what I'd like you to do is go ahead and pause the video and give this a try. I know from experience, it seems in class, sometimes it seems, oh, this isn't so hard. And then you go to actually work on the problem and the homework and you're like, oh, this is a lot harder than somehow there's a disconnect. So this is a good chance for you to actually check and make sure that this is making sense for you. So pause that video, try it out, and then we'll come back and go through it together. Okay, so let's take a look at this and see if we kind of got to the same spot. So we'll start by making a table. My input, or my independent variable, would be the day. And then my output, or my dependent variable, is how much money I'm going to make. So that first day when I sign my contract, I'm going to make $500. Actually, I guess we'll call that day 0. And then the first day I come to work and actually work, I'll make $100. So altogether, that gives me $600. That next day, day 2, that I come to work, I stay, do a good job, work hard, I'll pick up another $100. So that'll bring my total to $700. Do the same thing on day 3, which brings my total to $800. Day 4 gives me $900. By the end of the week, I'm at $1,000. All right, so there's our table. And let's go ahead and make a graph. So we'll put our horizontal and vertical axes on here. My horizontal axis is going to get my independent variable, or my input, which is the days. And then the vertical axis is going to get my output, which is that money. For the days, I'm just going to go by ones. It seems like pretty reasonable. And on the vertical axis with the money, since these are all in the hundreds, I think what I'd like to do is just go by hundreds here. So 100, 200, 3, 4, there's 500, 6, 700, there's 1,000, I think 8, 9, 10, yep. Right, so here's my signing bonus of $500. And after that first day, I make $600. Second day, I make $700. And since this is a straight line, 3 points is really enough for me to be able to just finish sketching this. Now you could have gone by maybe 200s or something like that over here. That would have been totally fine as well. So as long as it's a reasonable scale, if you've gone by ones, then you probably drew this line way up the page, and that's not a very realistic scale, but anything that's a realistic scale is fine. And then let's talk about a formula for this. So the amount of money I'm going to make, my output variable, or my dependent, is equal to my $500 signing bonus, there's my bonus, plus $100 per day. So we'll call this, my money is 500 plus 100, and we'll use a D for days, just to make that a little cleaner. Okay. And then we have one last thing to look at down here at the bottom. It says when we use a function to describe an actual situation, that function is referred to as a mathematical model. So there are 2 main branches of mathematics. There are applied mathematicians that do a lot of work with real-world models and real-world applications. And then there are pure mathematicians that do more of the theoretical or structural side of mathematics. Okay, and one of the areas within applied mathematics is mathematical models. So these models can be used for looking at how a disease spreads, how things like where's the optimal place to put cell phone towers so you have the best coverage. How do we set traffic lights so we get traffic moving in the most efficient manner? We don't have people sitting at red lights and long lines. We can model. I have a friend who does work modeling how blood flows through veins. She works with artificial hearts and things like that. We can look at aerodynamics and efficiency in cars, trains, planes. There's just a number of applications. But anytime we're looking at using a function for a real world situation, we call that a mathematical model.